Alrighty, welcome back, boys and girls. It's your main math man, Machine, coming to you live from Summit Academy. In this video, we're working on that Unit 2, Lesson 6, talking about some congruence, similarity, talking about those polygons, using those dilations and transformations. And so our warm-up for today, it says, choose whether each of these statements is true in all cases, in some cases, or in no cases. So in the first one, it says, if two figures are congruent, then they are similar. And we're going to say that that is for all cases. Congruent figures can be taken from one to the other by using rigid transformations. Similar figures use these same transformations, but also use dilations. If we don't do a dilation, the figures are still similar. So that's going to be the main difference is congruent cancels out or doesn't include dilations. For the second one, it says if two figures are similar, then they are congruent. In some cases it is. Again, congruent figures do not allow dilations. However, when you're talking about those rigid transformations, then they will be similar and congruent. For the third one, it says if an angle is dilated with the center of dilation at its vertex, the angle measure may change. In no cases does that happen. And we say the dilations will take rays of the angle to themselves, so it will not change the measure of the angle. So when you're making those dilations, the angle measure should stay the same. Underneath that, it says, let's look at a square and a rhombus. Pyria says these polygons are similar because their side lengths are all the same. Claire says these polygons are not similar because the angles are different. Do you agree with either Pyria or Claire? Explain your reasoning. So take a second, pause the video if you need to, and talk about whether you agree with Pyria or with Claire. So then it says, I agree with Claire. The angle measure in similar polygons are the same, so these polygons cannot be similar. Pyria is not right. The side lengths of these polygons are the same, but that is not enough to conclude that they are similar. For number 2, it says, now let's look at these rectangles ABCD and EFGH. Jada says these rectangles are similar because all of the side lengths differ by 2. And Lynn says these rectangles are similar. I can dilate AD and BC using a scale factor of 2 and AB and CD using a scale factor of 1.5 to make the rectangles congruent. Then I can use a translation to line these rectangles, line up these rectangles. Do you agree with either Jada or Lynn? Explain your reasoning. Let's go ahead and pause the video, take a second to kind of look these over, think for yourself whether you agree with one or the other or neither. Alright, so a couple things going on with this one, so to make sure you can pause, jot all these down for yourself. If you need to write inside of the boxes, feel free to, again, use your paper as needed. So it says, for number 2, it says, I disagree with both Jada and Lynn. Jada is right that the side lengths all differ by 2, but the scale factor between the short sides of the rectangles and the scale factor between the long sides are not the same. This means that the two rectangles are not similar. So the two scale factors between each of those rectangles have to be the same. Lynn is correct because the scale factor for dilating one set of sides cannot be different than the scale factor for dilating the other set of sides. So just be careful when you're talking about similar polygons. The ratio between those two side lengths and those scale factors has to be the same. On the back, it reads like this. It says points A through H are translated to the right to create points A prime through H prime. All of the following are rectangles. So it goes and lists those 4 shapes. Which is greater, the area of the blue rectangle, DFCE, or the total area of the yellow rectangles, KH prime, C prime, J, and LJE prime, A prime. So take a second to try to figure out, okay, you're comparing those two shaded lengths. Which do you think is greater? So it says they are actually equal. You can show that the rectangle G prime KJL is composed of triangles FHC and DEA. So make sure you can kind of find those endpoints. Again, if you need to highlight on your paper, feel free to use the highlighter, or if you need to use the colored pencil that's in there in your geometry toolkit, please do. Then it says, and the rectangle JC prime, B prime, E prime is composed of triangles GFD and triangle BEC. So underneath of it, the current do now, before you even worry about the cards, I want you to make sure that you're writing these following statements under where it says 7.3. So these are factual statements I want to make sure you guys are including before you do this activity. So it says two rectangles are similar if the side lengths are proportional. Then it says two rhombuses are similar if the angles are congruent. Then it says all squares are similar. So those are some factual ideas I want you guys to keep in your head as you're moving to this next activity. So where it has that, I want you to find someone else in the room who has a card with a polygon that is similar but not congruent to yours. When you have found your partner, I want you to work with them to write a sentence that explains how you know the two polygons are similar. So remember, let me actually put that underlined as well. Again, they are not congruent, but they could be similar. And I just want you to explain, again, write a sentence or two explaining how you know. So again, a sentence starter would look like this. It says, we know our polygons are similar because, and then you fill in the blank. So make sure you're using the sentence starter. Again, feel free to ask questions. And as always, super slam that subscribe button.